Hello everyone, so in this one shot I'm going to discuss units and dimensions, then significant figures, vectors, errors and its propagation, then instruments like Vernier caliper, screw gauge, spherometer. I'm going to discuss significant figures, errors and instruments in detail. So if you have not covered this area till date, so it will be highly beneficial if you watch this video till very end. And I will cover around 26 problem types which can be formed from these areas. So without any further delay, let's begin the session. We will see around 6 problem types, and in significant figures around 4 problem types, and in vectors around 5 problem types, and in errors and its propagation around 4 problem types, and in Vernier caliper and screw gauge 3 problem types each. And we'll also discuss spherometer because there was a question based on this instrument in one of the JEE paper. Now let us start with the very first problem type, which is based on dimensional formula. So the dimensional formula of angular impulse is, right, so we have to find the angular impulse, and we know that angular impulse is change in angular momentum. So the dimensional formula of angular impulse will be same as the dimensional formula for angular momentum. So angular momentum can be written as mvr, where m is the mass, v is the velocity, r is the distance, right? So the dimension of L will be same as the dimension of the right hand side. So it will be for mass we're going to use m raised to power 1. For velocity is displacement upon time, so displacement is L raised to power 1 divided by t raised to power 1, and r is basically the distance, so that will be L raised to power 1. So this comes out to be m raised to power 1, L raised to power 2, t raised to power minus 1. So the dimensional formula for which option is correct? So option 4 is the right answer. Now let's see this question. Given below are two statements. Statement 1, Planck's constant and angular momentum have same dimension, and second statement is linear momentum and moment of force have same dimension. Okay, let us find the dimension of Planck's constant. So we have to think about a formula which contains Planck constant. So I'm going to use energy of a photon, which is E equals to h nu, where nu is the frequency. So the dimension of h will be given by dimension of E by nu, where E is the energy, and the dimension of energy will be m raised to power 1, L raised to power 2, t raised to power minus 2, and the dimension for frequency will be t raised to power minus 1. So this will give us m raised to power 1, L raised to power 2, t raised to power minus 1. So that is the dimension of Planck's constant. Now for angular momentum, we're going to use mvr. We have just calculated this in the last question, and in the last question it was m L2 t minus 1, m L2 t raised to power minus 1. So if you compare their dimensions, yes, their dimensions are same. So statement 1 is correct. Now linear momentum and moment of force. Linear momentum is mass times the velocity, and moment of force is nothing but the torque. So torque is rf, r cross f. So the dimension of P will be same as the dimension of mv. So it will be m raised to power 1, L raised to power 1, t raised to power minus 1. And dimension for torque or moment of force will be same as the dimension of r times f, and r is length. Force can be written as mass upon acceleration. Force can be written as mass times acceleration. So m raised to power 1, and the dimension for acceleration will be L raised to power 1, t raised to power minus 2. So it will be m raised to power 1, L raised to power 2, t raised to power minus 2. So if you compare, their dimensions are not same, right? So these two dimensions are not same, so statement 2 is incorrect. So statement 1 is true, but the statement 2 is false. So option 1 is the right answer. Now let us see one more illustration based on the same problem type. If capital G be the gravitational constant and U be the energy density, then which of the following quantity have the dimension as that of root of UG? Right, so let us find the dimension for this, or let me solve this by using the unit method. So what is the unit of G? We know the formula, a universal law of gravitation, F is equals to G m square divided by r square. So G can be written as F r square divided by m square. Force is kilogram meter second raised to power minus 2, and r will be meter square R square will be meter square, and M, that will be kilogram square, right? So this will give us kilogram inverse meter cube second raised to power minus 2. Now the unit for U, that is the energy density. Energy density is the energy per unit volume. So we have energy in the numerator upon volume. So the unit for this U will be kilogram meter square second raised to power minus 2, and the volume will be meter cube. So that will be kilogram meter raised to power minus 1 second raised to power minus 2. Now let us take the product of these two units. So GU, its unit will be, kilogram will get cancelled out, and then we have M square and then second raised to power minus 4. And the root of this will be M second raised to power minus 2. So meter, so it will be meter second raised to power minus 2, right? So let us see the dimension for option 1. So it is pressure gradient per unit mass. So pressure gradient is dP by dx divided by mass. Pressure is force upon area. So it will be, for force will be kilogram, force is mass times acceleration, meter second raised to power minus 2. Area will be m square, and this dx is nothing but the distance. So m and mass is kilogram, right? So this will give us meter raised to power minus 2 second raised to power minus 2. That is incorrect. Now for gravitational potential, so gravitational potential will be gm by r, right? So that is the formula for gravitation potential due to a point mass. So let us find the unit for this. So g is kilogram inverse meter cube second raised to power minus 2. Mass is kilogram divided by meter. So it gives us meter square second raised to power minus 2. Again, it is not same as meter second raised to power minus 2. Energy per unit mass. So energy per unit mass. So energy is kilogram meter square second raised to power minus 2, and mass is kilogram. Again, it is not same as meter second raised to power minus 2. Force per unit mass. So so force upon mass, that will be acceleration, which is meter second raised to power minus 2. Yes, so we got option 4 as the right answer. Now let us another illustration based on the same problem type. So we have given two lists. We have given list. So on the list we have a physical quantity, list 1, and in the list 2 we have given the dimensions, and we have to match the physical quantity with the given dimensions. So torque. So torque is R times F. So for the dimension of torque will be L raised to power 1, M raised to power 1, L raised to power acceleration. So L raised to power 1, T raised to power minus 2. So that will be M raised to power 1, L raised to power 2, T raised to power minus 2. So 1, 2, minus 2. So A corresponds to 4. So if you look at the option 1 and option 4 are incorrect. Now let us check for B, magnetic field. So we can use any formula which contains magnetic field. So force on a charged particle will be QVB, right? So B can be written as F divided by QV. So the dimension for magnetic field will be M raised to power 1, L raised to power 1, T raised to power minus 2 divided by, for charge, Q can be written as current times the time. So that will be ampere, or current dimension times T. And V is the velocity, that is L T raised to power minus 1. So this will give us M raised to power 1, and it will be T raised to power minus 2 A raised to power 1. So 1 minus 2 A raised to power, sorry, minus 1. It should be minus 1, right? So B corresponds to 3. So it means option 3 should be the right answer, because in the option 2 they have given B corresponds to 2. So similarly we can check for other physical quantities and we can match. Now let us see the next problem. Given below are two statements. Statement 1 is dimensions of specific heat is L raised to power 2, T raised to power minus 2, K raised to power minus 1. Second statement is the dimension of gas constant is ml raised to power 2 t raised to power minus 1 k raised to power minus 1. Okay, right. So let us let us look at the formula which contains specific heat capacity. So we know that Q, which is the heat supplied, will be ms delta T, where delta T is the change in the temperature. So specific heat capacity can be written as Q divided by m delta T, and heat has the dimension of energy. So if we take the dimensions, so for energy it will be m raised to power 1 L raised to power 2 T raised to power minus 2, and for mass it will be m raised to power 1, and for delta T it will be K, right, which is the dimension for temperature. So this m will get cancelled out. So L raised to power 2 T raised to power minus 2 K raised to power minus 1. So yes, statement 1 is correct. And dimension of gas constant. So in gas constant, we can use ideal gas equation. So PV is equals to nRT, right? So here n is the number of moles. So gas constant can be given as PV divided by NT. So if you look at the dimension given, they have not taken moles into account. So it means statement 2 is incorrect, right? It does not have moles, but we will get moles if we calculate the dimension for R. So statement 2 is incorrect. So if you look at the option, statement 1 is correct, but the statement 2 is incorrect. So option 2 is the right answer. Now let us see another question based on the same problem type. The dimensional formula of latent heat. So we know that latent heat will be given as, we can get latent by this formula. Q is equals to m times L, where Q is the heat, m is the mass, L is the latent heat capacity, latent heat. So L will be Q by m. So if you take the dimension on both sides, so Q will be m raised to power 1, L raised to power 2, T raised to power minus 2. Mass is m raised to power 1, so that will be L raised to power 2, T raised to power minus 2, or m raised to power 0. So it will be L, so option 2 is the right answer. Now let us see this question. The de Broglie's wavelength associated with the particle of mass m and energy E is given by h upon root of 2me. The dimensional formula for Planck's constant is, okay, right? So dimensional formula. So we have to find dimensional formula for Planck's constant. So we can use any formula. No need. You don't have to use this formula. Right, so I can use E is equals to h nu, and by this we will also get the same dimension. So dimension of h will be same as dimension of E by nu, which will be m raised to power 1, L raised to power 2, T raised to power minus 2 divided by T raised to power minus 1. So that will be m raised to power 1, L raised to power 2, T raised to power minus 1. So it will be option 1, right? Option 1 is the right answer. Now we have to match the physical quantity with the respective dimension. So let us check. So in the list ones, A, coefficient of viscosity. So we have to figure out we have to remember the formula which contains coefficient of viscosity. So if you remember the viscous force, Stokes law, viscous force is given as 6 pi eta RV, where 6 pi is dimensionless, where eta is the coefficient of viscosity. So eta can be written as F viscous force divided by R times V times 6 pi. So the dimension of eta will be given by this. So it will be force is m raised to power 1, L raised to power 2, T raised to power L raised to power 1, T raised to power minus 2, divided by R is length. So it will be L raised to power 1, V is L raised to power 1, T raised to power minus 1. 6 pi is dimensionless, so one L will get cancelled out. So it will be m raised to power 1, L raised to power minus 1, T raised to power minus 1. So that is the dimension of coefficient of viscosity, 1 minus 1 minus 1. So A corresponds to 3. Now let us see the option. So option 1 is incorrect, option 2 is incorrect, option 4 is incorrect. So option 3 is the right answer. So in such questions, you don't have to calculate dimension for each physical quantity. By 1 or 2 dimension, like dimensions, you'll be able to find the answer. Right, so if epsilon naught is the permittivity of free space and E is the electric field, then the dimension of epsilon times E square. Right, so if you remember energy density, so energy contained per unit volume in electric field will be given as half epsilon naught E square, right? So we can use this formula. So we can say the dimension of epsilon naught E square will be given by the dimension of energy density. So dimension of epsilon naught E square will be same as dimension of energy density, which is energy per unit volume. So energy is m raised per 1, L raised per 2, T raised per minus 2, and for volume it will be L raised per 3. So it will be m raised per 1, L raised per minus 1, T raised per minus 2. So 1 minus 1 minus 2. So option 4 is the right answer. Now let us see the next problem type, which is based on principle of homogeneity. So it means if we have an equation, the dimension of left hand side should be same as the dimension of right hand side, and if we are adding two physical quantities together, their dimension should be same. For example, in this equation, p is added with a by v square, so the dimension of p will be same as the dimension of a by v square. Similarly, the dimension of v will be same as the dimension of b, right? And the dimension of right hand side will be same as the dimension of the left hand side. So we're going to use this principle. So the equation of the state of real gas is given by P plus A by V square times V minus B equals to RT, where P, V and T are temperature, pressure, volume and temperature. And R is the universal gas constant. The dimension of A by B square is similar to that of. So we have to find the dimension of A by B square. So we know that the dimension of P will be same as the dimension of A by V square. So we can say dimension of A will be same as the dimension of PV square. Similarly, the dimension of V is same as the dimension of B. So if I want to find A by B square dimension, it will be same as the dimension of A divided by dimension of B square. And A will be having same as PV square dimension, and B square will be nothing but V square. So this V square will get cancelled out. So we can say the dimension of A by B square is same as the dimension of pressure. So option 2 is the right answer. Now let us see this case. So if mass is written as K C raised to power P G raised to power minus 1 by 2 H raised to power 1 by 2, then the value of P will be, where constants have their usual meanings, with K is a dimensionless constant. So in this equation, K is dimensionless, so we again use a principle of homogeneity. The dimension of left hand side should be same as the dimension of right hand side. So dimension of mass will be same as, and K is dimensionless, so don't have to consider K. It will be same as the dimension of C raised to power P, G raised to power minus 1 by 2, H raised to power 1 by 2. So this, they have mentioned constants have their usual meaning. So this G is universal gravitational constant, which is given by F r square upon m square, and Planck's constant will be given by E by nu, where E is the energy, nu is the frequency. Now let us find the dimension of G. So it will be m raised to power 1, L raised to power 1, T raised to power minus 2, R square will be L square, M square will be M square, right? So this will give us m raised to power minus 1, L raised to power 3, T raised to power minus 2. Similarly, the dimension of H will be given by a dimension of E by nu. So m raised to power 1, L raised to power 2, T raised to power minus 2, and the frequency is T raised to power minus 1. So that will be m raised to power 1, L raised to power 2, T raised to power minus 1. Now, and C is the speed of light in vacuum, and it is speed, so that will be L T raised to power minus 1. So now let us substitute the dimensions of G, H and C in this equation. So the dimension of M will be same as dimension of C, which is L T raised to power minus 1 raised to power P, and M raised to power minus 1, L raised to power 3, T raised to power minus 2 raised to power minus half, then M raised to power 1, L raised to power 2, T raised to power minus 1 raised to power 1 by 2. And left hand side is nothing but M raised to power, where M mass, right? So M raised to power 1, L raised to power 0, T raised to power 0. Now let us club the exponents for length, time and mass on the right hand side. So we have M raised to power 1 by 2 plus 1 by 2. Then we have L raised to power P minus 3 by 2 plus 1. Then we have T raised to power minus P plus 1 minus 1 by 2. Now we have to compare exponents in the left hand side with the right hand side. So we can say 1 is equals to 1 if we compare the exponent for mass, and 0 will be equals to P minus 3 by 2 plus 1. and we have to find the value of p only, right? So from this, p comes out to be 3 by 2 minus 1, which is 1 by 2. So option 1 is the right answer. Now let us see this question. Based on the same problem type, a force is represented by F, which is ax square plus bt raised to power 1 by 2, where x is distance, t is time. The dimension of b square by a. So the dimension of ax square should be same as the dimension of bt raised to power 1 by 2, and their dimension should be same as the dimension of force. So dimension of F will be same as the dimension of ax square will be same as the dimension of bt raised to power 1 by 2. Okay, so if we compare this first equation, so we have left hand side can be written as m raised to power 1, l raised to power 1, t raised to power minus 2. And this can be written as dimension of a times x is distance, so that will be l raised to power 2. So dimension of a will be m raised to power 1, l raised to power minus 1, t raised to power minus 2. Now if we check the dimension for f and bt raised to power 1 by 2, so we can say m raised to power 1, l raised to power 1, t raised to power minus 2 will be equals to b dimension of b times t. T is time, so that will be t raised to power 1 by 2. So dimension of b will be m raised to power 1, l raised to power 1, t raised to power minus 2 minus 1 by 2. So b will be m raised to power 1, l raised to power 1, t raised to power minus 5 by 2. Now we have to square this. So if we square this, it will become 2, it will become 2, this 2 will get cancelled out. Now we got dimension of a, dimension of b. Now let us find the dimension of b square by a, which will be m raised to power 2, l raised to power 2, t raised to power minus 5 divided by m raised to power 1, l raised to power minus 1, t raised to power minus 2. So this will give us m raised to power 1, l raised to power 3, t raised to power minus 3. So 1, 3, minus 3. So option 1 is the right answer. Let us see this question. Consider two physical quantities a and b related to each other as E equals to b minus x square by at, where E, x and t have dimensions of energy, length and time. The dimension of a, b. So here the dimension of b should be same as the dimension of x square, because we are adding them, we are subtracting them, and the dimension of b minus x square upon at square should be same as the dimension of e, right? So let us simplify this. So the dimension of b will be what? It is x is length, so that will be l square. So we got the dimension of numerator, which is l square. So dimension of e will be same as the dimension of b minus x square divided by at. So in the numerator, the dimension is l square. A, we have to find the dimension of a, and t is time, t raised to power 1. So dimension of a will be same as l square upon t dimension of e, and dimension of e is m raised to power 1, l raised to power 2, t raised to power minus 2. So that will give us m raised to power minus 1, l will get cancelled out, and t raised to power 1. So or l raised to power 0. So we got dimension for a and the dimension of, and we have to find the dimension of AB. So what is the dimension of B? That is L square. So AB, dimension of AB will be m raised to power minus 1, t raised to power 1, l raised to power 0 times l raised to power 2. So that will be l raised to power 2, m raised to power minus 1, t raised to power 1. So option 2 is the right answer. Now let us see another problem based on the same problem type. So we have given the equation of a stationary wave, which is 2a sine 2 pi nt by lambda cos 2 pi x by lambda. Which of the following is not correct? So here the dimension of n by lambda is t. So this has to be dimensionally, it should be dimensionless, right? So 2 pi nt by lambda, so that should be dimensionless, so we can put it equals to 1. 2 pi is again dimensionless, so n by lambda should have the dimension of 1 by t, and 1 by t is t raised to power minus 1. So statement 1, and we have to find which of these options are incorrect. So statement 1 is incorrect, so that is the answer. right? Similarly, we can check for other options. Now let us see this question. Applying the principle of homogeneity of dimensions, determine which one is correct, where T is the time period, G is the universal gravitational constant, M is mass, and R is the radius of orbit. Okay, so we have to check. So now let us remember the formula. So we know that time, so T square is equals to 4 pi square upon times r cube divided upon gm, right? So that is the formula which you must have studied in gravitation, right? So if you know the formula, you'll be able to find the answer quite easily without doing any dimensional analysis. So here if you compare, it will be r cube, right? So option 3 is the right answer, and if you even check the dimension, you will get the same answer. Now let us see the next question based on the same problem type. So what is the dimensional formula of a b raised to power minus 1 in the equation p plus a by v square times v minus b equals to rt? Well, let us have their usual meaning. So we have to find let us first find the dimension of a and b, and then we can find the dimension of a b raised to power minus 1. So, and by the principle of homogeneity, dimension of p will be same as the dimension of a by v square. So dimension of p will be same as a by v square, and dimension of v will be same as dimension of b, right? So dimension of a will be pv square, right? Same as the dimension of pv square, and dimension of b is nothing but l cube. And pressure is force upon area, so m raised to power 1, l raised to power 1, t raised to power minus 2 upon l square, and volume square will be l raised to power 6. So dimension of a will be m raised to power 1, l raised to power 5, t raised to power minus 2, and dimension of b is l cube. So we have to find a b raised to power minus 1 dimension, which is nothing but a by b. So a by b will be m raised to power 1, l raised to power 5, t raised to power minus 2 divided by l cube. So which comes out to be m raised to power 1, l raised to power 2, t raised to power minus 2. So 1, 2, minus 2. So 1, 2, minus 2, option 3 is the right answer. Now let us see this question. Consider the efficiency of Carnot's engine is given by eta equals to alpha beta upon sine theta log to the base e beta x upon kt, where alpha and beta are constants. T is the temperature, K is the Boltzmann constant, theta is the angular displacement, and x has the dimension of length. So we have to check, then choose the incorrect option, right? So we need to find the dimension of beta, we have to find the dimension of alpha inverse x, we have to find the dimension of eta inverse sine theta, and the dimension of alpha. Right, so let us find that. So first of all, you should remember that the dimension of kT is same as the dimension of energy, which you have studied in KTG, right? So the average kinetic energy is given as 3 by 2 kT. So dimension of kT will be same as energy, which is m raised to power 1, l raised to power 2, t raised to power minus 2. And this beta x by kt should be dimensionless. So beta x by kt, it should be dimensionless, so you can put it equals to 1. So dimension of beta will be same as dimension of kt by x. Kt has a dimension m raised to power 1, l raised to power 2, t raised to power minus 2, and x has a dimension of length, so that is l. So it will be m raised to power 1, l raised to power 1, t raised to power minus 2. So we got the dimension of beta. Right, so statement 1 is, so this is beta has a dimension of same as force. So statement 1a should not be the right answer, because we have to find the incorrect statement. Now let us find the dimension of alpha, beta, alpha, right? So beta, we got the dimension of beta. Sine theta is again is dimensionless. Eta, dimension of eta will be same as dimension of alpha, beta. Log itself is dimensionless, sine theta is dimensionless, so the dimension of eta will be same as dimension of alpha and beta. Again, efficiency is dimensionless, so dimension of alpha will be same as dimension of 1 by beta, which is m raised to power minus 1, l raised to power minus 1, t raised to power 2. So dimension of alpha raised to power minus 1, which is same as beta, right? and dimension of alpha raised to power minus 1 times x. Let us find the dimension. So alpha raised to power minus 1 will be having the dimension same as beta, which is m raised to power 1, l raised to power 1, t raised to power minus 2. X is length, so that will be m raised to power 1, l raised to power 2, t raised to power minus 2, which is the same dimension as energy. So statement 2 B cannot be the right answer because we have to find the incorrect option. Dimension of eta inverse sine theta is same as alpha beta. Yes, alpha beta is dimensionless, eta inverse sine theta is also dimensionless. So this can't be the answer. Dimension of alpha is same as beta, that is incorrect. So this is the answer, right? Right, this is based on the same concept. I'm keeping this as a homework. You can try this on your own, and the answer for this will be C, right? Similar question, and the answer for this will be D. So I'm keeping these two questions as a homework. Right, so now let's see the next problem type where we have to derive formula by using dimension analysis. So if force F, velocity V and time T are considered as fundamental physical quantity, then the dimensional formula of density will be. So here what we can do, we can write density as some constant times f raised to power alpha, v raised to power beta, t raised to power gamma, right? And then we're going to use dimension analysis. So the dimension of left hand side should be same as the dimension of right hand side. So let us apply dimension analysis. So if I take the dimensions, k is dimensionless constant, so we can ignore it. So dimension of force will be m raised to power 1, l raised to power 1, t raised to power minus 2 raised to power alpha. Velocity, v is velocity, so l t raised to power minus 1 raised to power beta. T is time, so t raised to power gamma. Now let us club the exponents. So m raised to power alpha, l raised to power alpha plus beta, and t raised to power minus 2 alpha minus beta plus gamma. And the left hand side is density, and density is mass upon volume. So mass is m raised to power 1, volume is l cube, so l raised to power minus 3. So if we compare the exponents on left hand side with the right hand side, so 1 will be equals to alpha, and alpha plus beta will be equals to minus 3. So it means beta will be minus 3 minus 1, that will be minus 4. And the dimension of t will be 0. So minus 2 alpha minus beta plus gamma should be 0. So minus 2 minus 4 plus gamma. So that gamma comes out to be 4 minus 4 plus 2. So that will be minus 2. So it also density can be written as k times f raised to power 1, v raised to power minus 4, t raised to power minus 2. So it should be 1 minus 4 minus 2. So 1 minus 4 minus 2. I think negative is missing here. It should be this, right? T raised to power minus 2. So option 2 is the right answer. Now let's say another question based on the same problem type. If time t, velocity v, and the angular momentum L are taken as the fundamental units, then the dimension of mass in terms of t, v, and L. So again, we're going to use the same approach. So we can write m as some constant times t raised to power alpha, v raised to power beta, and L raised to power gamma, right? Where L is angular momentum. Let me take it as capital L. Now we're going to compare dimension of left hand side with the right hand side. So it will be m raised to power 1, l raised to power 0, t raised to power 0. K is dimensionless, t is time, so t raised to power alpha. V is speed, so L t raised to power minus 1 raised to power beta. L is angular momentum, which is mvr. So m is m raised to power 1, l raised to power 1, t raised to power minus 1. V, r is L raised to power gamma. So this can be written as t raised to power alpha, l t raised to power minus 1 raised to power beta. This can be written as m raised to power 1, l raised to power 2, t raised to power minus 1 raised to power gamma. Now let us club the exponents. So m raised to power gamma, l raised to power beta plus 2 gamma, t raised to power alpha minus beta minus gamma. So here we have m raised to power 1, l raised to power 0, t raised to power 0. So 1 is equals to gamma, 0 is equals to beta plus 2 gamma. So beta comes out to be minus 2 times 1, that will be minus 2. and alpha minus beta minus gamma will be 0. So gamma will be alpha minus beta, alpha, okay, right. So we have to find alpha. So alpha will be beta plus gamma, right? So beta is minus 2, gamma is plus 1, so that will be minus 1. So it means m can be written as k times t raised per alpha, which is minus 1, v raised per beta, which is minus 2, L raised per gamma, which is 1. So minus 1, minus 2, 1. Minus 1, minus 2, 1. So option 4 is the right answer. Now let us see another question based on the same concept. The speed of a wave produced in water is given by V equals to lambda raised per A, G raised per B, rho raised per C, where lambda, G and rho are wavelength of wave, acceleration due to gravity and density of water, respectively the value of A, B and C respectively. So again we going to use dimension analysis. We'll take the dimension of left hand side, compare the dimension of left hand side with the right hand side. Left hand side is speed, so that will be m raised per 0, L raised per 1, T raised per minus 1. Lambda is wavelength. Wavelength has a dimension of length. So L raised per A. G is acceleration due to gravity. It will be having a dimension of acceleration. L raised per 1, T raised per minus 2, raised per beta. Rho is density, which is mass upon volume. So mass is m raised per 1. Volume can be written as L raised per minus 3 raised per C. Now let us club the exponents. So m raised per C, L raised per A plus B minus 3C and T raised per minus 2B. Now we have to compare the exponents. So 0 is equals to C, 1 is equals to A plus B minus 3C and minus 2B is equals to minus 1. So this is 0 and B is 1 by 2. So it will be 1 minus A plus 1 by 2 minus 3 times 0. So A comes out to be 1 by 2. So A is 1 by 2, B is 1 by 2, C is 0. So option 1 is the right answer. Now let us see the next problem type where we have to check the dimensional correctness of the formula. So we have given assertion and reason. So assertion is the time period of oscillation of a liquid drop depends on the surface tension. If the density of the liquid is P or rho, basically this is rho, and the radius of the drop is R, then T, which is the time period, will be given by K times root of rho R cube upon S raised to 3 by 2 is dimensionally correct, where K is dimensionless. So a dimensionally correct equation will be having same dimension for left hand side and the right hand side. So we have to check what is the dimension of right hand side, and if it comes out to be the same as the dimension of time, then it is dimensionally correct. So let us find that. So dimension for rho, which is density, will be m raised per 1, L raised per minus 3. Dimension for R will be same as dimension of length, and S is surface tension, and surface tension has a dimension same as force per unit length. So force that will be m raised per 1, L raised per 1 minus 2 per unit length. Now let us substitute these values. So we in the right hand side, so we have so dimension of K root rho R cube divided by S raised by 3 by 2 will be, K is dimensionless, so we can just ignore it, root of m raised per 1, L raised per minus 3, R cube, L cube and S raised per 3 by 2. So that will be m raised per 3 by 2 and T raised to power minus 3. Okay, right. Let us simplify this. So this comes out to be m raised to power 1 minus 3 by 2, L raised to power 0, T raised to power 3, root of that. So it comes out to be 1 by 2 m raised to power minus 1 by 2, T raised to power 3, root of that. Clear? So it does not comes out to be same as the dimension of time. So state assertion is incorrect, right? Using dimension analysis, we get right hand side have different dimension than that of the time. So reason is correct, right? So we are getting that only. We are getting some other dimension other than time. So option D is the right answer, where A is false but R is true. Right, let's see the next problem type, where we have to compare two system of units. So velocity V, acceleration A in two systems of units 1 and 2 are related as, so V2 is n by m square V1 and A2 is A1 by m times n respectively, where m and n are constants. The relations for distance and time in two system respectively. So distance and time, right? So distance in the first system is L1 and the distance in second system is L2, and similarly time in first system is T1 and time in the second system is T2. Right, so velocity is given, acceleration is given, and we know that if you want to find the like what is the relation between acceleration, velocity and distance. So v by t gives us acceleration, right? So if we want to find time, so time is nothing but v by a. So let us find that. So v2 by a2 will give us t2, right? So v2 by a2, if we divide them, so n by m square times v1 divided by, and d2 a2 can be written as a1 by m times n. So this can be written as n v1 upon m square times mn upon a1. So m will get cancelled out, so it will be n square by m v1 by a1. So that will be t2. And v1 by a1 is nothing but t1. So t2 is equals to t1 times n square by m. So t2 will be n square by m. So t2 is n square by m. So if you look at the first option, t2 is equals to n square by m times t1, right? But in the other options, it is something else. So option A is the right answer, right? Now we got time. If you want to find the length, so we know that speed is given as displacement upon time. So we can use this and we can find the relation between the lengths. So I hope this concept is clear. Now let us see the question based on like the large, like suppose if you want to measure large distances, there are certain units that we use, and there will be factual questions based on that. So you have to remember that there are three very important units. One is astronomical unit, then parsec, and one light year. Now let us see one by one. So what is one astronomical unit? It is the average distance between the earth and the sun, and it is given by 1.5 into 10 raised per 11 meter. And 1 parsec is defined as, let me show you what is 1 parsec. So if I consider a length of one astronomical unit, and let us say at a distance, at say certain distance, it subtends an angle of 1 arc second, then this distance is defined as 1 parsec. Okay, and it comes out to be 3.086 into 10 raised per 16 meters. And 1 light year is the distance traveled by light in 1 year, and it will be 9.46 into 10 raised per 15. Now if we compare these, then we can say parsec is greater than light year, and light year is greater than astronomical unit. So this is the order. Now let us see the question came from this particular section. Given below are the two statements. Statement 1, astronomical unit, parsec and light years are units for measuring the astronomical distances. Yes, statement 1 is correct. And statement 2, it compare these, right? So we know that parsec is greater than light year and light year is greater than astronomical unit. So statement 2 is incorrect. So statement 1 is correct, statement 2 is incorrect. So option 2 is the right answer. Now there can be a question based on where we have to find the size of the distant object. Now let us see one of the illustration which came in one of JEE paper. The distance of sun from earth is 1.5 into 10 raised by 11 meter, and its angular diameter is 2000 seconds, arc seconds, right? When observed from the earth, the diameter of the sun. Suppose this is earth and we are observing sun, and we have given angular diameter. So what does it mean? That the diameter, sun's diameter subtends an angle of 200 arc seconds. So this angle is 2000 arc seconds. So what you have to remember, 1 degree is equivalent to 60 arc minute, and 1 arc minute is equivalent to 60 arc seconds. So 1 degree is equivalent to 3600 arc seconds, right? And we know that 1 degree is equivalent to, or pi radian is equivalent to 180 degrees. So pi radian is equivalent to 180 degrees. So 1 degree is equivalent to pi by 180 radian. So it will be pi by 180 radian is equivalent to 3600 arc second. So here we have given angular diameter in arc seconds. So 2000 arc second can be written as pi by 180 times 2000 divided by 3600 radian. So like this we can convert arc seconds into radians. So the diameter of the sun. So let us say d is the diameter of the sun. So if we know the formula, like where we have to find the arc length, right? If this is L, this is radius, and this is theta, then L is r theta. So here we have to find the diameter. So diameter will be the distance, which is given as 1.5 into 10 raised by 11 times the theta. Now theta is this value. So 1.5 into 10 raised by 11, theta will be pi by 180 times 2000 divided by 3600, right? Now if we simplify this, let me quickly check the answer. So it will be 1.5 times 3.14 times 2000 divided by 180 divided by 3600. So this gives us 0.014 into 10 raised to power 11, or I can write this as 0.14 into 10 raised to power 10. Okay, or I can write this as 1.4 into 10 raised to power 9. So if you look at option C, that is the closest answer. So C is the answer of this question. I hope this concept is clear. Now let us see the next concept, which is now let us see the next concept, which is significant figures. So here let us understand what is significant figures. Suppose we want to measure the length of a specimen. Suppose this is the specimen, and we are measuring the length by using a scale, right? And these are the markings. And let us say this mark is 3 centimeter, and then we have markings like this: 3.1, 3.2, 3.3, 3.4, 3.5. So let us say the end of this specimen lies between 3.5 and 3.6 centimeter. And you have measured the length. You are saying the length is 3.54 centimeter, right? Now in this measurement, we are certain about 3, we are certain about 5, but this last digit is uncertain. So we will see, we can say the number of significant figure in the measurement of the length of this specimen will be 3, right? So we have to count all significant figures, or all certain figures, and the last uncertain figure. So it will be having 3 significant figures, right? Now let us see some of the rules that we have to keep in our mind while finding the number of significant figures. Now the first rule is all non-zero digits are significant. So if I'm writing 2, 3, 5, 4, then there will be 4 significant figures. And the second rule is all zeros occurring between the non-zeros digits are significant. So if I'm writing 2, 3, 0, 0, 8, 9, it will be having 6 significant figures. So I'm counting those zeros. And the third rule is all zeros to the left of a non-zero digit are not significant. So if I'm writing 0.0023, then these zeros, like like before 2 are non-significant. So it will be having 2 significant figures. And if I'm writing, so in the, let us say the rule 4, if a number ends in zeros and we are not showing any decimal place, right, that are not to the right of a decimal, the zeros are not significant. So if I'm writing 1500, it means it will be having 2 significant figures. But suppose if I write 15.0 or 1500.0, then it will be having 5 significant figures, right? If I'm showing decimal, it means we have measured this up to 1 decimal place. So it will be having 5 significant figures. Right, so now let us see some of the questions which can be formed from this area. So write the number of significant digits in A, B, C and D. So in A, no decimal is shown, so we can say it will be having 4 significant figures. It is measured up to 1 decimal place, it will be having 4 significant figures. It is measured up to 2 decimal places, so it will be having 5 significant figures. And in this case, we'll be having 4 significant figures, right? We don't have to count these zeros. Now let us see the arithmetic operation where we have to round off up to certain significant figures. So let us see the rule for addition and multiplication. So in addition, suppose if we have 24.36, 0.0623, 256.2, and 24.36 is round off up to so it is measured up to 2 decimal places, it is measured up to 4 decimal places, it is measured up to 1 decimal place. So you have to round off your answer up to 1 decimal place in this case, because in this we have the least number of decimal places, right? So if we simplify this, so 24.36 plus 0.0623 plus 256.2, so this will give us 280.6223, and we have to round off this to 1 decimal place, so it will be 280.6. so that should be the answer. In case of multiplication or division, we have to consider significant figures. Now 252, 25.2 has 3 significant figures, 1374 has 4 significant figures, 33.3 has 3 significant figures. So our answer should be up to 3 significant figures. So let us simplify this. So 25.2 times 1374 divided by 33.3. So sorry, let me again calculate. 25.2 times 1374 divided by 33.3. So it will give us 1039.783784. Suppose this, we are getting this as the answer. So now we have to round this up to 4 significant figures, right? So it can be written as, sorry, 3 significant figures. So that will be 1040. So that should be the answer. Or we can write this as 1.04 times 10 raised to power 3. Okay, so either you can write it as 1040 or you can write it as 1.04 times 10 raised to power 3. Now let us say the rule for rounding off. Suppose if I have 6.37, say 7, right? If I want to round this up to say 2 decimal place, so that is the second decimal place, you have to look at the third decimal place. If this number is greater than 5, then you have to increase 7 by 1. So this will be 6.38, right? What happens if we have a 5 instead of 7? Suppose if we have 6.375. Now in this case, the third decimal place is 5. Now you have to look at the second decimal place. If this is odd number, you have to increase odd number by 1. So this will become 6.38. But suppose if it is 6.345. Now here we have a even number. If you want to round this up to 2 decimal places, you have to retain even number. So this will be 6.34. So you have to remember these rules. Let us see the question based on this. Round off the following numbers to 3 significant digits. Right, so we want to round this up to 3 significant digits. It is 15462. So here we have a 4 and to the right of this we have 6. So it can be written as 15500, right? So that is we have round up this number up to 3 significant figures. Now if you look at this is 7 and to the right of this we have 4, so it will be 14.7 only, right? Now we have 14.75, so to the right of this we have 5 and this is an odd number, so we have to increase odd number by 1, so that will be 14.8. Now this is 14.650, so here we have a even number and this is 5, so we have to retain even number, so that will be 14.6 into 10 raised per 12, right? Basically it is 10 raised per 12. So I hope this concept is clear. Now let us see the next problem type, which is based on vectors. So here it is cross product. So if we have given two vectors A and B, then their magnitude will be given as AB sine theta, where theta is the angle between the two vectors. And if we have both the vector lying on a plane, say this is A vector and this is B vector, and this angle is theta, then we can find the direction of A cross B by curling our finger from A vector to B vector. So if I curl my fingers from A to B, thumb is pointing in the upward direction. So the direction of A cross B will be normal to this plane. So that is A cross B. And B cross A will be in the opposite direction. So let us see the question. So A is a vector quantity such that magnitude of A is non-zero constant. Which of the following expression is true for A vector? Now it's not a unit vector, it has certain magnitude. So here we have A dot A. So since both the vectors A dot A, so it is the dot product. So what is dot product? Let me quickly tell you what is dot product. So A dot B is given as AB cos theta, where theta is the angle between the two vectors, and the result will be a scalar quantity, but in this case in cross product it will be a vector quantity. So A dot A can be written as A times cos 0, which is nothing but A square, so option A is incorrect. A cross A is negative, right? So A cross A will be what? It will be 0, right? Because A sine 0, that will be 0. So B is incorrect. A cross A is 0, so C is correct. A cross is positive, that is incorrect. So option C is the right answer. Now let us see this question. If the projection of 2i cap plus 4j cap minus 2k cap on I cap plus 2j cap plus alpha k cap is 0, then the value of alpha will be, if the projection of a vector on another vector is 0, then we can say the two vectors are perpendicular to each other. When two vectors are perpendicular, their dot product is 0. So if this vector is A, this vector is B, then we can say A dot B should be 0. And how to find the dot product? So in this case, you have to take the product of the individual x, y and z components and then add them. So it will be 2 times 1 plus 4 times 2 plus minus 2 times alpha, that should be 0. So 2 plus 8 minus 2 alpha will be 0. So alpha comes out to be 10 by 2, that will be 5. So 5 is the answer. Now let us see the next problem type based on the addition and subtraction of a unit vector. So if I have two unit vector, let us say A cap and B cap. If I want to add them, right? So their resultant will be given as 2 times magnitude of one vector and any of these two vectors times cos of theta by 2, where theta is the angle between the two vector and the magnitude of their subtraction of their difference, or like if you subtract these two vectors, then the resultant will be 2 times 1 times sine theta by 2, right? So this you can remember. Now let us see this question. Which of the following relation is true for two unit vectors A and B making an angle theta to each other, right? So from this, if we take the ratio A cap minus B cap divided by A cap plus B cap, that will give us tan theta by 2, right? So option B is the right answer. Now let us see the next problem type, which is based on the addition and subtraction of vectors with equal magnitude. So when we have two vectors with equal magnitude, we can write A plus b, its magnitude can be written as root of a square plus a square plus 2a square cos theta, where theta is the angle between the two vector, and here I have taken magnitude of a and b same as a, and this can also be written as 2a cos theta by 2. So any of these two formula we can use, and if you take the subtraction, so a minus b, it can be written as root of a square plus a square minus 2a square cos theta, which comes out to be 2a sine theta by 2. Okay. Now in this question we have given two vectors a and b have equal magnitudes. If magnitude of a plus b is equals to 2 times the magnitude of a minus b, then the angle between a and b will be, right? So I'm going to use these first formulas. So root of a square plus 2a square cos theta is 2 times root of a square plus a square minus 2a square cos theta. Okay, so we can eliminate a square also, and we can square this, so we will get, okay, right, so root of 2a square will be common, so then we have root of 1 plus cos theta, and this will be 2 times root of 2a square times root of 1 minus cos theta. So this will get cancelled out. Now let us square on both sides. So 1 plus cos theta will be equals to 4 times 1 minus cos theta. So this will give us 5 cos theta equals to 3. So theta comes out to be cos inverse 3 by 5. So option C is the right answer. Right, so now let us see the next problem type, which is based on the component of a vector along a particular direction. So we have given vector A, which is 2 I cap plus 3 j cap minus k cap. B vector is I cap plus 2 j cap plus 2 k cap, and the magnitude of the component of vector A along vector B. So if we want to find the component, suppose we have given vector A, which is in this particular direction, and we want to find the component in this direction. So we and the angle between them, let us say, is theta. So the component will be given as A dot B cap, right? So if we take the dot product of A vector with the unit vector in the direction where we want to find the component, right? So this will give us the component. So this will be A, magnitude of A, magnitude of B, cos theta, right? And this we have to calculate. And what is cos theta? And cos theta can be written as A dot B cap divided by A vector B cap, right? So this we have to calculate, A cos theta. And how to find the dot product between them? Okay, right, so let us find the value of, so let us find A dot B. Right, so in this question we just have to find the component. So A dot B will be what? So A dot B cap can be written as B vector divided by magnitude of B. So A vector is 2 I cap plus 3 j cap minus k cap dot with B vector, that is I cap plus 2 j cap plus 2 k cap divided by its magnitude, that will be root of 1 square plus 2 square plus 2 square. So this can be written as, so let us take the dot product of the numerator. So it will be 2 times 1 plus 3 times 2 minus 1 times 2 divided by 4 plus 4, 8 plus 1, 9, root 9 will be 3. So it will be 2 plus 6 minus 2 divided by 3. So it comes out to be 2. So 2 is the answer. Suppose if they ask you what is the angle between the two vectors, we can use this, right? Now let us see the next problem type, which is based on errors. So first let us see what is absolute error and what is relative error. So let us see this illustration, and from this illustration I will explain what do we mean by absolute error and the relative error. So a student in a lab measures thickness of a wire using screw gauge. The readings are 1.22 millimeter, 1.23 millimeter, 1.19 millimeter, and 1.20 millimeters. And the percentage error is x upon 121%, the value of x. So we have to find the value of x. So let me first write down the observation. So we have 1.22 millimeters and 1.23, 1.19, 1.20. Now what we have to do, let us find the mean of these, right? These observations. So let us find the mean. Let me call this as, these observations is AI and the mean is A mean, right? So it will be 1.22 plus 1.23 plus 1.19 plus 1.20 divided by 4. Or I can write this as 1.20 times 4 plus 0.02 plus 0.03 plus 0.00 minus 0.01 divided by 4. So that will be 1.21, right? So when we simplify this, we will get 1.21 millimeter. So that is the mean. Now what you have to do, you have to find the deviation of individual observation from the mean, right? So AI minus A mean. And if I take the modulus of that, so the difference of 1.22 with 1.21 will be 0.01 millimeter, and again 1.23 minus 1.21, that will be 0.02 millimeter. 1.19 minus 1.21, that will be 0.02 millimeter, and 1.20 minus 1.21 will be 0.01 millimeter. Now that is known as the absolute error. These are the absolute errors in individual observation. Now let us find the mean absolute error. So let me call this as delta A mean. So it will be the mean of these absolute errors. So 0.01 plus 0.02 plus 0.02 plus 0.01 divided by 4, because there are 4 observation. So it comes out to be 2 plus 2, 4, 6. So 0.06 divided by 4, which will be 0.015 millimeter, right? So we got mean absolute error. So relative error is defined as delta A mean divided by A mean. So this comes out to be 0.015 divided by 1.21, right? And here we have to find the percentage error. So percentage error is relative error times 100. So it will be 1.5 divided by 1.21, and this is given as x by 121. So from this, so if I remove this decimal, so we can clearly see that x comes out to be 150. So 150 is the answer of this question. I hope the concept of absolute error, mean absolute error, or percentage error is clear to you. Now let us move to the next problem type, which is based on the propagation of error. Now in case of addition and subtraction, let me take an example. Suppose we have given a resistor R1, it is 10 ohms, and there is an error of say 0.5 ohms, right? So that is given R1, and we have given R2, another resistor. Resistance is 20 ohms and the error is, let us say, again 0.5. So this is given, and we want to find the error in the equivalent combination of these, the series combination of these two resistors, so which is R1 plus R2. So when we are adding two physical quantities, then their errors will also get added up. So the error in their series combination will be sum of the individual errors. So this will be 0.5 plus 0.5. So this comes out to be 1 ohms. So we can write R equivalent will be what? So R1 plus R2 will be 10 plus 20, 30. So 30 plus minus 1. So that should be the answer. And in this case, the relative error will be 1 by 30 and the percentage error will be 100 by 30. And if we take the difference, suppose we have a length L, which is L2 minus L1, and L2 is given as 10 plus minus 1 centimeter, and L1 is given as 5 plus minus 0.5 centimeter, right? And again, in case of subtraction, we have to, if you want to find the maximum error, then maximum error in L will be nothing but the sum of the individual errors. So whether we are subtracting or adding, doing addition, we have to add up the error. So this will give us 1 plus 0.5, so that will be 1.5 centimeter. So we can write L as L2 minus L1 will be 10 minus 5, so that will be 5 plus minus 1.5. Got it? So that's what we have to do in case of addition and subtraction. And usually like I haven't seen any question based on this particular problem type in JEE. Usually they ask questions based on multiplication and division, and if there are exponents involved. Let us see those type of questions. So propagation of error in multiplication and division. If you look at a physical quantity P, it depends upon A, B, C and D. And we have given their exponents are also given, like A has an exponent 2, B has 3, C has minus 1, D has minus 1 by 2. Or I can write this as A raised to power 2, B raised to power 3, C raised to power minus 1, D raised to power minus 1 by 2. So if in such cases, the relative error in P will be equals to 2 times the relative error in A plus 3 times the relative error in B plus 1. So I'm not taking minus 1 because we want to find the maximum relative error that is possible in P. So it will be 1 times delta C by C plus 1 by 2 times delta D by D. So basically I have just multiplied relative error with the exponents. So this you have to remember. And if you want to find the percentage error, we can multiply this equation with 100. So if you do that, the percentage error in the measurement of A, B, C and D is given as 1, 2, 3, 4% respectively. The percentage error in the measurement of P. So that will be 2 times 1 plus 3 times 2 plus 1 times 3 plus 1 by 2 times 4%, right? So this will be in percent. So 2 plus 6 plus 3 plus 2. So that will be 13%. So option 1 is the right answer. Now let us see this question based on the same problem type. So here we have given assertion and reason. So assertion is given as a spherical body of radius 5 plus minus 0.1 millimeter. So 5 is the value and 0.1 is the error in the measurement. Having a particular density is falling through a liquid of constant density. The percentage error in the calculation of its terminal velocity is 4%, right? So if you remember, the terminal velocity is given as 2 by 9 r square g sigma minus rho divided by eta, where sigma is the density of the body, rho is the density of the surrounding viscous fluid, eta is the coefficient of viscosity, g is acceleration due to gravity, r is the radius of the body, vt is the terminal velocity. The percentage error in the calculation. So here density, no error is given in densities, and no information is given about the coefficient of viscosity and g. So we can treat g rho, sigma minus rho by eta. This term is exact, there is no error. So Vt is directly proportional to square of the radius. Okay, so we can write it as Vt some constant times r square. Now in this particular case, the relative error in terminal velocity will be 2 times the relative error in resistor. Okay, so there is no error in K. So this can be, so the relative error in the radius is, let us find that. So 2 times 0.1 divided by 5. So it will be 0.04. Now the percentage error in terminal velocity will be 0.04 times 100. So that comes out to be 4%. So assertion is correct. So the error in the measurement of terminal velocity will be 4%. Now the reason will, let us see the reason. The terminal velocity of a spherical body falling through a liquid is inversely proportional. This reason is incorrect, right? It is directly proportional to square of the radius. It is not inversely proportional. So in the which option is correct? Assertion is true, but reason is false. So option 4 is the right answer. Let us see this question. So here we have given z as a square x cube y raised to power 1 by 2. So the relative error in z will be equals to 2 times relative error in a plus 3 times relative error in x plus 1 by 2 times relative error in y. If we multiply this equation with 100, we will get the percentage error. So this will be, and the percentage error in xy is given as 4 and 12%, where a is a constant, so this term will be 0, right? So this term will be 0. So it will be 3 times 4 plus half times 12. So 12 plus 6, so it comes out to be 18%, right? So 18% is the answer. Now let us see this question. A torque meter is calibrated to reference standards of mass, length and time, each with 5% accuracy. After calibration, the measured torque with this torque meter will have a net accuracy. So what is torque? Torque is given as R times F, right? R cross F. Now if I take the dimension, it will be L raised to power 1, M raised to power 1, L raised to power 1, T raised to power minus 2, which is M raised to power 1, L raised to power 2, T raised to power minus 2, right? Now they are saying mass, length and time, all these three are measured up to 5% accuracy. So we have the percentage error, that is 5% in all these quantities. So the relative error in measurement of torque will be delta M by M plus 2 times delta L by L plus 2 times delta T by T. Again, I'm taking plus 2, not minus 2, because we always have to find the maximum error. So this comes out to be, and let us multiply this with 100. So this will be 5 plus 2 times 5 plus 2 times 5 in percentage. So it comes out to be 10 plus 10 plus 5, 25%. So option B is the right answer. Now let us see this question. So in an experiment to find acceleration due to gravity using simple pendulum, time period of 0.5 second is measured from a time of 100 oscillations with a watch of 1 second resolution. So the error in the measurement in time is 1 second. So, and we have measured 100 oscillations. So the error in the time for one oscillation will be 1 second divided by 100. So that will be 0.01 second. And the time period is 0.5 second. And we want to find the acceleration to gravity, right? So the accuracy in the determination of G. So we have to find percentage error in G. So we know what is the time period formula, that will be 2 pi root L by G. Let us square this and find G in terms of other physical quantities. So G can be written as 4 pi square L by T square. 4 pi square is constant. So we can say relative error in G will be relative error in L plus 2 times relative error in time. No information is given about, okay, right, so that is given. If the measured value of length is 10 centimeter and the error is, or accuracy is 1 millimeter, so that is the error. So delta, this is delta L and this is L. The accuracy in the determination of G is found to be x%, the value of x. So let us multiply this with 100. Let us substitute the value. Delta L is 1 millimeter and 10 centimeter can be written as 100 millimeter plus 2 times delta T is 0.01 and delta and T is 0.5 times 100. So this comes out to be 1 plus 2 upon 0.5, which will be 5. So x will be 5. Now let us see this question. Based on the same problem type, the time period of a simple pendulum is given by this formula. The measured value of the length of the pendulum is 10 centimeter, error is 1 millimeter. and the time for 200 oscillation of the pendulum is found to be 100 seconds. Using the clock of 1 second resolution, the percentage accuracy in the determination of G. This question is exactly similar to last question, so I'm keeping this question as a homework. So when we try to solve this, you will get option 2 as the answer. Right, so in the experiment of Ohm's law, a potential difference of 5.0 volt is applied across the ends of a conductor of length 10.0 centimeters and the diameter is 5.00 millimeter. The measured current in the conductor is 2.00 ampere. The maximum permissible percentage error in the resistivity. So here what we have given, there is a conductor. We have given length and we have given how much potential we are applying, and diameter is also given, and the current is also given, right? And we have to find the resistivity. So we know that resistance of a conductor is given as rho L by A, where A is the area of cross section, so that will be pi d square by 4. And here by Ohm's law, R can be written as V upon I, so it can be written as V by I. So if we want to find the error in resistivity, so rho can be written as pi d square by 4 times V divided by L times I. Okay, and if you look at the question, they have not clearly mentioned like what is the accuracy. So in this type of question, you have to check up to what decimal place we have measured that value. For example, potential difference is 5.0 volts, so it is measured up to 1 decimal place, so the error or the accuracy is 0.1 volt. So 0.1 is the error in the measurement of potential difference, so delta V will be 0.1 volt. Similarly, delta L will be 0.1 centimeter and delta D is 0.01 millimeter and delta I is 0.01 ampere. Clear now? V is given as 5.0 volt, L is given as 10.0 centimeter and D is given as 5.00 millimeter and I is given as 2.00 ampere. Now we have to use this data where pi by 4 is constant. This is constant, so we can say the relative error in density in resistivity will be 2 times the relative error in diameter plus 1 times the relative error in potential difference plus 1 times the relative error in length plus 1 times the relative error in current, right? Percentage error we have to calculate, multiply this with 100. Now let us substitute the values. So 2 times delta D. So delta D is 0.01 millimeter divided by 5 plus delta V is 0.1 divided by 5. Delta L is 0.1 divided by 10 and delta I is 0.01 divided by 2. Multiply this with 100. So if we multiply 100 inside, so we will get 2 by 5 plus 10 by 5 plus 10 by 10 plus 1 by 2. So this will give us 1, this will give us 2, so that will be 0.4 and this will be 0.5, so it will be 3.9%. So option 1 is the right answer. Now let us see this question. The radius of a sphere is measured to be 7.50 plus minus 0.85 centimeters. Suppose the percentage error in its volume is x, the value of x to the nearest, right? So we have to nearest integer basically. So delta R is given as 0.85 centimeter and R is given as 7.50 centimeter. And volume of a sphere is 4 by 3 pi r cube. So 4 by 3 is constant. So the relative error in volume will be 3 times the relative error in in the radius. And if we want to find the percentage error, let us multiply this with 100. So it will be 3 times 0.85 divided by 7.5 times 100. So this will give us 2.5 and this will give us 40. So it will be 8.5 times 4. So it comes out to be 34, right? So 34%. So 34 is the answer. Now let us see this question. The resistance R is V by I, where V is 50 plus minus 2 volt, I is 20 plus minus 0.2 ampere. The percentage error in resistance is x%, the value of x to the nearest integer. So we have to find the error in R. So delta relative error in R will be delta V by V plus delta I by I. So percentage error we have to calculate. Multiply this with 100. So delta V is 2, V is 50, delta I is 0.2 and I is 20 times 100. Let us multiply 100 inside, so we'll get 4 plus 20 by 20, that will be 1, so that will be 5%, right? So 5% is the answer. Let us see this question. In order to determine the Young's modulus of a wire of radius 0.2 centimeter measured using a scale of least count, so that is the error, right? 0.001 centimeter. So this will be delta R, this is R. The length 1 meter measured using a scale of least count 1 millimeter. So this will be delta L and this will be L, right? A weight of mass 1 kg measured using a scale of least count 1 gram. So that will be delta M and this will be M. Was hanged to get the elongation of 0.5 centimeter. Let us say this is small l, which is the elongation, and this is the error in elongation. What will be the fractional error? Basically they are saying fractional error, and in the option they have given percentage. So basically we have to find the percentage error in the measurement of Young's modulus. So delta y by y times 100 we have to calculate. So first let us write down the formula. So we know that Young's modulus is defined as stress upon strain, and in this case stress will be mg by area of by the area of cross section, which is pi r square, and the strain will be L by capital L. So this can be written as mg divided by pi r square L times capital L. So here no information is given about acceleration due to gravity, so we can treat g to be exact. There is no error in g. Pi is a dimensionless constant, and again it is exact. It has no error. So we have to consider only mass, capital L, small l, and r. So the relative error in Young's modulus will be relative error in mass plus relative error in length plus 2 times relative error in the radius plus 1 times the relative error in the elongation. And we have to find the percentage error. Let us multiply this with 100. So delta m by m. So delta m is 1 gram and m is 1 kilogram or 1000 grams. Delta L is 1 millimeter and L is 1 meter, or it can be written as 1000 millimeter. 2 times delta R. Delta R is given as 0.001 centimeter and R is given as 0.2 centimeter. Elongation delta L is given as 0.001, that is the error, and elongation is 0.5, and we have to multiply this with 100. So let us multiply all the terms with 100. So we'll get 1 by 10 plus 1 by 10 plus 0.2 by 0.2 plus 0.01 by 0.5. Sorry, 0.1 by 0.5. So this decimal will get cancelled out. This decimal will get cancelled out. So that will be 0.2 plus 1 plus 0.2. So that will be 1.4. So 1.4% is the answer. So option 4 is the right answer. Now let's see this question. In an experiment for estimating the value of focal length, now this is another problem type where I'm going to use differentiation to find the relative error or the percentage error. In an experiment for estimating the value of focal length of a converging mirror, image of an object is placed at a distance of 40 centimeter from the pole. So we have a converging mirror and u is given as 40 centimeter. Object is placed at a distance of 40 centimeter from the pole of the mirror and is formed at a distance of 12 centimeter from the pole, and v is given as 120. These distances are measured with a modified scale in which there are 20 small divisions in 1 centimeter. So 1 centimeter is divided into 20 parts. So the least count of that scale will be, so least count will be 1 divided by 20 centimeter. So that will be 0.05 centimeter. So we got the least count, that is the error in the measurement of u and v, the value of error in the measurement of focal length of the mirror. Now let us see the formula. So we know that in case of a mirror, 1 by f is given as 1 by v plus 1 by u, right? So what I'm going to do here, I will differentiate both sides. So this can be written as minus 1 by f square times delta f is equals to minus 1 by v square times delta v minus 1 by u square times delta u, or I can write delta f by f is equals to f times delta v upon v square plus delta u upon u square. Again, we have to take both the terms to be positive because we want to find the maximum error in the measurement of focal length. And what is focal length? So let us let us find the focal length, and we are getting okay. So 1 by f. So u will be v will be minus 120, and u is minus 40. So that will be 120 will be the LCM. So minus 1 minus this will be 3. So minus 4 by 120, that will be minus 1 by 30. So focal length is minus 30 centimeter. So we got the focal length. So the so delta f by f, its maximum value will be 30 centimeter times delta v. So delta v is 0.05 centimeter divided by v square. V square is 120. So square plus delta u is 0.05 divided by 40 square, right? So let us simplify this and we have to find the percentage error, right? Value of error in the measurement of the focal length is 1 by k. Achha, error we have to find, right? Okay, let me take this f on the other side. So that will give us error in f. So 30 square. So this will give us 4, and here we will get 4 by 3. So this will be 0.05 will be, we can take it out. So 1 by 16 plus 9 by 16. So this will be 0.05 times 10 by 16. Or we can write this as 1 by 32. And this is given as 1 by k. So k comes out to be 32. So 32 is the answer of this question. I hope this concept is clear to you. Now let us another problem based on the same concept. Two resistances are given as R1 is 10 plus minus 0.5 ohms, R2 is 15 plus minus 0.5 ohms. The percentage error in the measurement of equivalent resistance when they are connected in parallel. So we know 1 by R equivalent will be given as 1 by R1 plus 1 by R2 when two resistors are in parallel. So here delta R1 is given as 0.5 ohms and R1 is 10 ohms. Delta R2 is given as 0.5 ohms and R2 is given as 15 ohms. So what I'm going to do, again I'm going to differentiate both sides. So I will get minus 1 by R equivalent square times delta R equivalent minus 1 by R1 square delta R1 minus 1 by R2 square delta R2, and we have to find the percentage error. So delta R equivalent divided by R equivalent is equals to R equivalent times delta R1 by R1 square plus delta R2 by R2 square. So we have to find percentage error, multiply both side by 100. And now let us plug in the value. What is R equivalent? We can use this formula. So R equivalent will be 10 times 15 divided by 10 plus 15. So it will be 150 divided by 25. So that will be 6. Now let us plug in the values. So R equivalent is 6. Delta R1 is 0.5 divided by R1 square. So that will be 10 square plus delta R2 is 0.5 divided by R2 square, that will be 15 square, and that should be times 100. Now let us take this 100 inside the bracket. So we will get 6 times 50 by 100 plus 50 by 15 times 15. So this will give us 3, and that will be 2, right? So and this will give us 1 by 2. So let us multiply 6 inside. So we will get 2 plus 2 by 9 times 6. So that will be 2 plus this will be 2 and this will be 3. So 4 by 3. And it will be 10 by 3. 10 by 3 and 3.33. 6. Sorry, this should be 3, not 2. This should be 3. And this will give us 9 plus 4, that will be 13 by 3. So it comes out to be 4.33. So option 3 is the right answer. So now let's start instruments. So the very first instrument that we're going to discuss is Vernier caliper. Now in Vernier caliper there is a main scale. So this long one is a main scale, and we'll also define one main scale division, that is the smallest length which this main scale can measure. And this small one is which can slide over the main scale is known as the Vernier scale, and the smallest length which this Vernier scale can measure is known as the one Vernier scale division. These are the jaws, and we'll place a specimen between the jaws and we'll measure the length of the specimen. It can be the diameter of a sphere, it can be the length of a cylinder, right? Or even we can use this depth rod to measure the depth of a container. Usually the least count or the smallest length which the Vernier caliper can measure will be around 0.1 millimeter or 0.05 millimeter when we use it for round objects, or we can measure the length and we can also measure the depth, right? So now let us see what do we mean by the least count and the zero error. So least count or LC is the difference of one main scale division and one Vernier scale division. So that will give us the least count. And what is the zero error? When both the jaws of the instrument are locked together, when there is nothing between the jaws, if the zero of the Vernier scale is coinciding with the zero of the main scale, then we can say the zero error will be nil, right? But if the zero of the Vernier scale is to the right of the zero of the main scale, then there will be a positive zero error. And how we can find the positive zero error? It will be 0 plus, you have to first locate the division of the Vernier caliper, Vernier scale which is coinciding with the main scale. So if you look at this division, which is 8th division, it is coinciding with the Vernier main scale. So we can say 8 times the least count. In this particular case, they have taken least count as 0.01 centimeter. So that will give us the zero error, positive zero error. So in order to find the negative zero error, if the zero of the Vernier caliper, if zero of the Vernier scale is to the left of the zero of the main scale, then we'll be having a negative zero error. So in this case, it will be minus 1 main scale division plus, now you have to look for the division which is coinciding with the main scale. So 4th division is coinciding with the main scale. So 4 times the least count, which is 0.01 centimeter. The main scale a smaller division is 0.1 centimeter, so that will be minus 0.1 centimeter plus 0.04 centimeter, so that comes out to be 0.06 centimeter. So the negative zero error will be 0.06 centimeter. And if you want to measure the reading, then the reading will be given as it will be main scale reading plus n is the number of division of the Vernier caliper which is coinciding with the main scale times the least count minus 0 error. Okay, we'll see how we can use this formula to find the reading with the instrument. So now we know what is least count, how to find the 0 error. Now let us see the question based on these concepts. So the first question is 10 division, so which is based on the least count. 10 division of the main scale of a Vernier caliper coincides with 11 divisions of the Vernier scale. If each division of the main scale is 5 units, the least count of the instrument. So each division, so one main scale division is given as 5 units. So the least count will be 1 main scale division minus 1 Vernier scale division. And we have given 10 main scale division coincides with 11 Vernier scale division. So 1 Vernier scale division will be 10 by 11 main scale division, and 1 main scale division is 5, so that will be 50 by 11. So we can say it will be 5 minus 50 by 11, so that will be 55 minus 50 by 11, that will be 5 by 11. So 5 by 11 is the answer. Option 4 is the right answer. Another question based on least count. If 50 Vernier divisions are equals to 49 main scale division, so 50 Vernier scale division is equals to 49 main scale division of a traveling microscope, and on a smallest reading of the main scale is 0.5 millimeter. So one main scale division is 0.5 millimeter. Then the Vernier constant. Vernier constant is nothing but the least count, right? So least count of the traveling microscope will be. So from this relation we can find one Vernier scale division. So one Vernier scale division will be 49 by 50 main scale division. And we know one main scale division is 0.5. So that will be 49 by 50 times 0.5 millimeter. And that will give us, so that will be 0.1, this will be 10. So it will be 49 by 100 millimeter, or we can write it as 0.49 millimeter. Now we got one Vernier scale division, we know what is one main scale division. So least count will be, or Vernier constant will be, one main scale division minus one Vernier scale division. So 0.50 minus 0.49, so that will be 0.01 millimeter. So option 4 is the right answer. Another question based on least count. A Vernier caliper has 20 divisions on the Vernier scale, which coincides with 19 division of the main scale. So 20 Vernier scale division coincides with 19 main scale divisions. The least count of the instrument is 0.1 millimeter. So least count is given as 0.1 millimeter. One main scale division is equals to how much? So we have to find one main scale division, and least count is given. So one Vernier scale division can be written as 19 by 20 times main scale division. Let us take it as x. So least count is one main scale division minus one Vernier scale division, that is equals to 0.1 millimeter. One main scale division is x minus one Vernier scale division is 90 by 20 x. Now from this we can find the value of x. So x by 20 will be equals to 0.1 millimeter. So x comes out to be 2 millimeter. So option 2 is the right answer. Another question based on least count. Least count of the Vernier caliper is 1 by 20 n centimeter. So least count is given as 1 by 20 n centimeter. The value of one division on the main scale is 1 millimeter. So one main scale division is 1 millimeter. Then the number of division of the main scale that coincide with the n division of the Vernier scale. So n Vernier scale division, let us say it is equals to x main scale division, right? So this x we have to calculate. So we can say one Vernier scale division can be written as x by n main scale division. right? So and one main scale division is given as 1 millimeter, so that will be x by n millimeter. So one Vernier scale division. So least count is one main scale division minus one Vernier scale division, that is given as 1 by 20 n centimeter. So one main scale division is 1 millimeter and one Vernier scale division is x by n millimeter, and that is equals to 1 by 20 n centimeter. So 1 centimeter is 10 millimeter. So I can write this as 10 millimeter. So this we can eliminate this 0. So we get 1 by 2n. So right hand side is in millimeters, left hand side is in millimeters. So 1 minus x by n. So from this x by n will be 1 minus 1 by 2n. So that will be 2n minus 1 divided by 2n multiplied with n. So that will give us x. So it will be 2n minus 1 by 2. So option 3 is the right answer. Now let us see this question. Based on the same problem type, one main scale division of a Vernier caliper is equals to m unit. So one main scale division is equals to m units. If n division of main scale coincides with n plus 1th division of Vernier scale, so it means n times main scale division is equals to n plus 1 times Vernier scale division. We have to find the least count. So one Vernier scale division will be n divided by n plus 1 main scale division, which is m. So least count will be 1 main scale division minus 1 Vernier scale division. So that is m minus n upon n plus 1 times m. So which will give us m times n plus m minus mn divided by n plus 1. So that will be m divided by n plus 1. So option 3 is the right answer. Let us see another question based on least count. So one main scale division of a Vernier caliper is a, that is a centimeter, and n division of the Vernier caliper coincide with n minus 1th division of the main scale. So n Vernier scale division is equals to n minus 1 main scale division, or I can write this as n minus 1 times a in centimeters. So one Vernier scale division can be written as n minus 1 by n times a centimeter. So we got one Vernier scale division and we have to find the least count. So least count will be one main scale division minus one Vernier scale division. So that will be a minus n minus 1 times a by n. So this will be in centimeters. But we have to find answer in millimeters. So 1 centimeter equals to 10 millimeters. So that it will be NA minus NA plus A divided by N times 10 in millimeters. So that will be 10A by N. So 10A by N. So option 4 is the right answer. Let us see one more question based on the same problem type. A traveling microscope is used to determine the refractive index of a slab. 40 divisions are there in 1 centimeter of the main scale. So one main scale division will be 1 centimeter divided by 40. And 50 Vernier scale divisions are equals to 49 main scale division. So 50 Vernier scale division is equals to 49 main scale division. So one Vernier scale division will be 49 by 50 main scale division, which is 1 by 40 centimeter. So this will be 49 divided by 2000 centimeter. Then the least count of the traveling microscope is dash times 10 raised to power minus 6 meter. So least count will be one main scale division, which is 1 by 40 centimeter, minus one Vernier scale division, that is 49 by 2000 centimeter, right? So what we can do, let us multiply and divide with 50. So this will give us 1 by 2000 centimeter. So which is 0.5 into 10 raised to power minus 3 centimeter, or I can write this as 5 into 10 raised to power minus 4 centimeter. 1 centimeter is 10 raised to power minus 2 meters. So 5 into 10 raised to power minus 6 meters. So 5 is the answer. Now let us see another question based on the same problem type. So in a Vernier caliper, each 1 centimeter on the main scale is divided into 20 equal parts. So it means one main scale division is 1 centimeter upon 20. So that will be 0.05 centimeter. If 10th Vernier scale division coincides with 9th main scale division. So it means 10 Vernier scale division is equals to 9 main scale division. The value of Vernier constant. Vernier constant is nothing but least count of the instrument. So one Vernier scale division will be 0.9 times main scale division, and one main scale division is 0.05. So 0.05 centimeter. So that will be 0.045. So that will be, yes, 0.045 centimeter. Now the least count will be one main scale division minus one Vernier scale division. So it will be 0.05 minus 0.045, which comes out to be 0.005 centimeters. And we have to find answer as 10 raised to power minus 2 millimeter. So 1 centimeter has 10 millimeters. So this will be 5 into 10 raised to power minus 3 times 10 millimeter, or it can be written as 5 into 10 raised to power minus 2 millimeter. So the answer of this question will be 5. Now let us see this question based on the same problem type. A traveling microscope has 20 divisions per centimeter on main scale. So one main scale division will be 1 centimeter over 20. So that will be 0.05 centimeter. While its Vernier scale has total 50 divisions, and 25 Vernier scale divisions are equals to 24 main scale divisions. So 25 Vernier scale division is equals to 24 main scale division. Now from this, one Vernier scale division will be 24 by 25 times 0.05. So if I simplify this, so this will give us 0.01, and that will be 5. So if I multiply this with 2, this with 2, so it comes out to be 48.048, and that will be in centimeters. So we got Vernier scale division, we know what is main scale division, and we have to find the least count. So least count will be 1 main scale division minus 1 Vernier scale division. So 0.05 minus 0.048, so which is 0.02 centimeter. So option C is the right answer. Now let us see a question based on the zero error of a Vernier caliper. So here we have given assertion and reason. So assertion is given as, in a Vernier caliper, if the positive zero error exists, then while taking the measurement, the reading taken will be more than the actual reading. Right, so in this case, reading is more than the actual reading. That's why we have to subtract positive zero error. So assertion is correct. Now in the reason, the zero error in Vernier caliper might have happened due to the manufacturing defect or due to rough handling. That is also correct. So we'll have a zero error because of those defects. So we can say both assertion and reason are correct, but reason is not the correct justification for the assertion. So it will be option 2. So both A and R are correct, but R is not the correct explanation of assertion. Now let's see one more question based on the same problem type. So in a Vernier caliper, when both jaws touch each other, 0 of the Vernier scale shifts towards right, and its fourth division coincides exactly with the certain division on the main scale. So it means when both the jaws are locked together, we are getting some reading. So there will be positive zero error, right? And how we can find the positive zero error? It will be 0 plus the division of the Vernier scale, which is coinciding with the main scale, that will be 4 in this case, times the least count. So that is zero error. And it is given as, right, if the 50 Vernier scale division coincides with 49 main scale division and zero error in the instrument is 0.04 millimeter, then how many main scale divisions are there in 1 centimeter? Right, so from this, zero error is given as 0.04 millimeter. So least count will be 0.04 divided by 4. So that comes out to be 0.01 millimeter. So we got the least count, and we have given 50 Vernier scale division coincides with 49 main scale division. Now this will give us, so we can say one Vernier scale division will be 49 by 50 main scale division. And we know that least count is 1 main scale division minus 1 Vernier scale division. So this will be 1 MSD minus 49 by 50 MSD. So this will give us 1 by 50 MSD, and least count is given as 0.01 millimeter. So 1 MSD is equals to 0.01 times 50 in millimeters, so which is nothing but 0.5 millimeter. Now we got the main scale division, and how many divisions on the main scale corresponds to 1 centimeter. So if we divide 1 centimeter, right, so and one main scale division is equivalent to 0.5 millimeters. So 1 centimeter divided by 0.5 millimeter, so that will be 10 divided by 0.5, which will be 20. So we can divide 1 centimeter into 20 divisions. So option 3 is the right answer. Now let us see how we can find the reading, how we can find the reading using Vernier caliper. So let us see this question. So the Vernier, the 10 division of the Vernier scale are matching with 9 division of the main scale. Now when both the jaws are locked together, 0 of the Vernier scale is coinciding with the 0 of the main scale. So we can say there will be no 0 error, right? Now if we place a specimen, and suppose this is a sphere and we want to find the diameter of the sphere. So how we can find the reading? So let us see. So reading is main scale reading plus n times the least count minus 0 error. Now let us see these terms one by one. So what is main scale reading? So if you look at this, the 0 of the Vernier scale, this is the 0 of the Vernier scale. So the main scale reading is the reading on the main scale which is just to the left of the 0 of the Vernier scale. So this is the 0. So the reading to the left of 0 of the Vernier scale is 15, right? So we can say this reading, let me show it with red color. So this reading will be 15 millimeters. So it is main scale reading. So that will be 15 millimeter. And n is the Vernier scale division which is coinciding with the main scale. So if you look at this, 6th division. So 1, 2, 3, 4, 5, 6. 6th division is coinciding. So 6 times the least count. Now what is the least count? We know least count is 1 main scale division minus 1 Vernier scale division. And here main scale is in millimeters. So that will be 1 millimeter. And we have given 10 Vernier scale divisions are matching with 9 main scale division. So 10 Vernier scale division is equals to 9 main scale division. So 1 Vernier scale division will be 0.9 times main scale division. Now we can substitute this in this equation. So it will be 0.9 times 1 millimeter. So it comes out to be 0.1 millimeter. So we got least count. So we can substitute least count as 0.1 millimeter. 0 error is nil. So this comes out to be 15.6 millimeter. Now let's see one more question. Here again we have to find the reading, and we have given 9 main scale division are coinciding with 10 Vernier scale division, and 1 main scale division is 1 millimeter. So again we got the least count as same as the last question, that will be 0.1 millimeter. But in this case when both the jaws are locked together, 0 of the Vernier scale is to the right of the 0 of the main scale. So in this case 0 error will be given as 0 plus the division which is coinciding with the main scale. So in this case it will be 6th. 6 times the least count which is 0.1. So it will be 0.6 millimeter. Now we got the 0 error, and we want to find the width of this specimen. And if you look at the main scale reading, so the reading on the main scale which is to the left of the 0 of the Vernier scale is 14. So this will be main scale reading, which is nothing but 14 millimeter. And which division is coinciding with the main scale? So we can say this 6th one. So 6th division is coinciding. So reading is given as main scale reading plus n times the least count minus 0 error. So here main scale reading is 14 millimeter. N is 6, least count is 0.1 millimeter, and 0 error is 0.6 millimeter. So this will get cancelled out. So we will get 14 millimeter as the answer. Now let us see this question based on the same problem type. In an experiment with Vernier calipers of least count 0.1 millimeter, so least count is given. When two jaws are joined together, the zero of the Vernier scale lies right to the zero of the main scale. So if this is the zero of the zero of the Vernier scale lies to the right of the zero of the main scale. So this is the zero of the main scale and this is the zero of the Vernier scale. And we have given 6th division of the Vernier scale coincides with the main scale. So n is 6. So it will be having positive zero error. So positive zero error, it will be 0 plus n times the least count, which is 0.1 millimeter. So 0.6 millimeter will be the zero error in this case. While measuring the diameter of a spherical bulb, the zero of Vernier scale lies in between 3.2 millimeter to 3.2 centimeter and 33.3 centimeter mark, and the 4th division of the Vernier scale coincides with the main scale division. So when we are measuring, this is the zero of the Vernier scale and it lies between 3.2 and 3.3 centimeter. So the reading on the main scale, which is to the left of the zero of the Vernier scale, is 3.2. So main scale reading will be 3.2 centimeter. N is given as 4. So we can say reading will be main scale reading plus n times the least count minus 0 error, right? So main scale reading is 3.2 centimeter. N is given as 4. Least count of the instrument is 0.1 millimeter. Zero error is 0.6 millimeter. So it will be 3.2 centimeter minus 0.2 millimeter. And we have to find answer in centimeter. So this can be written as 3.20 centimeter minus 0.02 centimeter. So it will be 3.18 centimeter. So option 1 is the right answer. Now let us see one more question based on the same problem type. In a Vernier caliper, 10 divisions of the Vernier scale is equals to 9 division of the main scale. So this will give us the relation between Vernier scale division and the main scale division. When both jaws of the Vernier caliper touch each other, the zero of the Vernier scale is shifted to the left of the zero of the main scale. So zero of the Vernier scale is to the left of the zero of the main scale. So it means we have negative zero error. So how we can find the negative zero error? First, let us find the least count. So least count, so we have given 10 Vernier scale division matches with 9 main scale division. So from this, least count will be 1 main scale division minus 1 Vernier scale division, and 1 main scale division is given as 1 millimeter. So this will be 1 millimeter minus this will be 9 by 10 millimeter. So it will be 0.1 millimeter. So we got the least count. How to find zero error? It will be negative zero error. So it will be minus 1 main scale division plus n times the least count. So it will be minus 1 millimeter plus n in this case is 4. Least count is 0.1 millimeter. So this comes out to be minus 0.6 millimeter. So we got the zero error, and it is now observed that the zero of the Vernier scale lies between 30 and 31st division of the main scale, and 6th Vernier scale division scale division exactly coincides with the main scale. So main scale reading will be 30 MSD, right? Because if I show you the zero of the Vernier scale, to the left of this we have 38 division on the main scale, and here we have 31st, and the reading on the main scale to the left of the zero of the Vernier scale is 30. So it will be 30 times MSD. So reading is main scale reading plus n times least count minus 0 error. So here main scale reading will be 30 times MSD, which is nothing but millimeter, and n in this case is 6. Least count is 0.1 millimeter. Zero error is minus 0.6 millimeter. So that will be 30 plus 1.2. So it will be 31.2 millimeter or 3.12 centimeter. So if you look at the option C is the closest to our answer. So option C is the right answer. Right, so now let us see this question based on the same problem type. The diameter of a sphere is measured using a Vernier caliper whose 9 divisions of main scale are equals to 10 division on the Vernier scale. So 9 main scale division is equals to 10 Vernier scale division. So 1 Vernier scale division is 0.9 times main scale division. The shortest division on the main scale is 1 millimeter. It means 1 MSD is 1 millimeter. So that will be 0.9 millimeter. So we can find the least count. So 1 main scale division minus 1 Vernier scale division, that will be 0.1 millimeter. The main scale reading is 2 centimeter. Second division of the Vernier caliper coincides with the division of the main scale. So main scale reading is 2 centimeter. N is given as second division. So 2. If the mass of the sphere is 8.635 grams, the density of the sphere. So we can find the diameter. So diameter will be main scale reading plus n times the least count. Since no information is given about the zero error, so we can assume the zero error is nil. So minus 0 error. So this third term will be 0. So it will be 2 centimeter plus n times the least count, which is 0.1 millimeter. And we have to find answer in grams per cc. So I'm going to find diameter in centimeter only. So that will be 2 plus 2 times 0.01. So it will be 2 plus 0.02. So that will be 2.02 centimeter. So we got the diameter and we have to find the density of the sphere. So density will be mass upon volume. So that will be 4 by 3 pi r cube, or we can say d cube by 8. So this comes out to be 8. So this will give us 2. So it will be 6 m divided by pi d cube. So 6 times 8.635 divided by 3.14 times 2.02 cube, right? So if I simplify this, 6 into 8.635 divided by 3.14 divided by 2.02 cube. So it comes out to be 2.00 gram per cc. So option 1 is the right answer. Now let us see another question based on the same type. The Vernier caliper used for measurement has a positive zero error, that is 0.2. So zero error is plus 0.2 millimeter. If while taking a measurement, it was noted that 0 of the Vernier scale lies between 8.5 and 8.6 centimeter. And Vernier coincidence is 6. So n is 6 and this will be the main scale reading, right? Then the correct value of the measurement. So the reading will be main scale reading plus n times the least count minus 0 error. So here least count is given as 0.01 centimeter. So main scale reading is 8.5 centimeter. N is 6, least count is 0.01 centimeter, and 0 error is given as 0.2 millimeter. And we have to find answer in centimeters. So this will become 8.5 plus 0.06 minus 0.02 in centimeters. So it will be 8.56 minus 0.02, which is 8.54 centimeters. So option 2 is the right answer. Let us see another question. In an experiment of measuring the refractive index of a glass slab using a traveling microscope in physics lab, a student measures real thickness of a glass slab as 5.25 millimeters and apparent thickness of the glass slab as 5.00 millimeter. Traveling microscope has 20 divisions in 1 centimeter on the main scale. So one main scale division will be 1 centimeter divided by 20. So that will be 0.05 centimeter. And we have given 50 divisions of the Vernier scale is equals to 49 divisions on the main scale. So 50 Vernier scale division is equals to 49 main scale division. So from this one Vernier scale division will be 49 by 50 main scale division, and main scale division is 0.05. So 49 divided by 50 times 0.05 centimeter. So we got one Vernier scale division, we got one main scale division. The estimated uncertainty in the measurement of refractive index of the slab is, so we have to find the error in the measurement of the slab. So we know that apparent depth is equals to original depth divided by refractive index of the medium of incidence divided by refractive index of the medium of refraction, right? And we have to find the uncertainty in the measurement of refractive index. So basically, if and here the medium of refraction will be air, so we can say this will be d by mu. So mu is d by d apparent. So the relative error in mu will be sum of the relative error in the actual depth and the apparent depth. Now let us substitute the value. So we know so what is the error? So least count, let us find the least count. So least count will be 1 main scale division minus 1 Vernier scale division. So 1 main scale division is 0.05 centimeter. 1 Vernier scale division is 49 by 50 times 0.05 centimeter. So that will be 0.05 will be common. So 1 minus 49 by 50 in centimeters. So this comes out to be 0.05 divided by 50 in centimeter. So that will be 0.01, that will be 10. So it will be 0.001 centimeter. So we got the least count, and since we have measured the depth using this instrument, so the error will be, so delta D and delta D apparent will be nothing but 0.001 centimeter. So let us substitute the value. So delta mu is equals to mu times delta D is 0.001 centimeter divided by D. So actual depth, real depth thickness is 5.25, or it can be 0.525 centimeter plus 0.001 divided by 0.5. And how to and this mu, we can find this mu by using this formula. So D is original depth and apparent depth is 5. So this will be 105 divided by 100. So this will be 105 divided by 100. And we can take this, let us simplify this. So 1 upon 525 plus 1 upon 500. So we are getting this. So if we multiply 105 inside, so we'll get 1 by 100 equals to 1, that will become 1 by 5 plus 105 divided by 500. So this will be 21, and that will be 100. Multiply this with 20. So the LCM will be 100. So 20 plus 21, and then we'll be having 10,000 in the denominator. So it will be 41 divided by 10 raised per 4. And this value is given as x by 10 into 10 raised per minus 3. So this will cancel out with this. So x comes out to be 41. So 41 is the answer of this question. Let us see another illustration based on the same problem type. The Vernier constant of a Vernier caliper is 0.1 millimeter. So Vernier constant or least count, they are same thing. So this is the least count, and it has a negative zero error, which is minus 0.05 centimeter. While measuring the diameter of a sphere, the main scale reading is 1.7 centimeters. So that is main scale reading. And coinciding Vernier division is 5. So that is n. So correct diameter we have to calculate. So the reading will be main scale reading plus n times the least count minus 0 error. So main scale reading is given as 1.7 centimeter. N is given as 5. Least count is 0.1 millimeter. 0 error is minus 0.05 centimeter. And we have to find answer in centimeters. So let us convert this millimeter into meters. So it will be 1.7 plus 0.05 centimeter plus 0.05 centimeter. So that will be 1.8 centimeter. And we have to find answer in terms of centimeter only. So we can write this as, and this 1.8 centimeter is given as, say, x times 10 raised per minus 2. So it will be 180. So x will be 180. So 180 is the answer. Now let us see this question. The one division of the main scale of Vernier caliper reads 1 millimeter and 10 divisions of the Vernier scale is equals to 9 division on the main scale. So it means one main scale division is 1 millimeter and 10 Vernier scale division is equals to 9 main scale division. So one Vernier scale division will be 0.9 millimeter. So from this we can find the least count, that will be 0.1 millimeter. When the two jaws of the instrument touch each other, the 0 of the vernier lies to the right of the 0 of the main scale. So this is the 0 of the main scale, this is the 0 of the vernier scale. So we'll be having a negative 0 error. And the fourth division coincide with the main scale. So 0 error will be minus 1 main scale, sorry, it will be a positive, not negative. It will be a positive 0 error. And 0 error will be 0 plus n times least count. N is given as 4. Least count is 0.1. So that will be 0.4 millimeter. When a spherical bob is tightly placed between the two jaws, the 0 of the vernier scale lies between 4.1 and 4.2. So this is the 0 of the vernier scale. Here we have 4.1. Here we have 4.2 centimeter. So that will be the main scale reading. And n is 6, the diameter of the bob. So diameter will be main scale reading plus n times the least count minus 0 error. Main scale reading is 4.1 centimeter. N in this case is 6, least count is 0.1 millimeter and 0 error is 0.4 millimeter. We have to find answer in centimeters. So it will be 4.1 plus 0.06 minus 0.04. So that will be 4.12 centimeter. So it will be 412 into 10 raised per minus 2 centimeter. So 412 is the answer of this question. Now let us see the next instrument, and it is screw gauge, and it is more precise. Its least count is even smaller than the Vernier caliper, and we use screw gauge to measure the thickness of thin sheets, and its least count will be around 0.01 millimeter, even less than that. And we can also measure the diameter of thin rods. So this is the instrument. Here we have a linear scale, and this is the reference line, and there is a circular scale. So there are certain markings. There are certain markings on the circular scale, and when we rotate the circular scale, the spindle displaces in the forward direction. So if we rotate the circular scale, say by if we give one full rotation, the displacement in the forward direction of the spindle is nothing but the pitch, right? Now let us see. And we can place the specimen between the anvil face and the spindle face, and we can lock it. So once we lock the spindle and the anvil, we can measure the reading. Okay, so first let us see the 0 error and the least count. So how to find the least count? So least count will be pitch divided by number of divisions in circular scale. For example, if the pitch is say 0.1 millimeter and there are say 100 divisions in the circular scale, so the least count will become 0.001 millimeter, right? Now there can be 0 error, there can be nil zero error, positive or negative zero error. So when the zero on the circular scale is below the reference line, then there will be a positive zero error. It means the screw gauge is already showing some reading. And how to find the zero error? It will be 0 plus which division which is coinciding with the reference line? It will be 3. So it will be 3 times the least count, which is 0.01 millimeter. So this comes out to be plus 0.03 millimeter. If the zero of a Vernier, zero on the circular scale is above the reference line, so this is the reference line and 0 is above, right? Now in this case, there will be negative zero error and it will be minus 1 main scale division plus n times the least count. Now here n will be this mark, which is 48. So that is 48. And 1 main scale division in this case will be minus, say, 0.1 millimeter plus n is 48, least count is 0.01. So it will be minus 0.1 plus 0.48. So which comes out to be minus, sorry, so in this case they have taken 1 main scale division as 0.5 millimeter, right? So it should be 0.5. So this will give us minus 0.02 millimeters. Got it? So like this we can measure the zero error and the least count. Let us see some question based on least count. If in 5 complete rotation of the circular scale, the distance traveled on the main scale of the screw gauge is 5 millimeter, then and there are 50 total divisions on the circular scale, then the least count is 0.001. So for 5 rotation, distance traveled on the main scale is 5 millimeter. So it means pitch will be 5 millimeter divided by number of rotations, so that will be 1 millimeter. So least count is pitch divided by number of division on the circular scale, which is 50. So it comes out to be 0.02 millimeter. So assertion is incorrect. Least count is pitch upon total division on the circular scale. This is correct. So A is incorrect, R is correct. So option 1 is the right answer. Now let us see how we can measure the reading by using Vernier, by using screw gauge. So here we have given in the main scale has only millimeter marks. So it means 1 main scale division is 1 millimeter. And in 1 complete rotation, the screw advances by 1 millimeter. So pitch is 1 millimeter, because in 1 rotation it is advances by 1 millimeter. So least count is pitch divided by number of division on the circular scale. So number of division on circular scale, so that will be 1 millimeter divided by 100. So there are 100 divisions on the circular scale, so that comes out to be 0.01 millimeter. Okay, so again in even in this case, reading will be given as main scale reading plus n times the least count minus zero error. Since no information is given about the zero error, so we can assume it to be nil. So how to measure? Look at this vertical line and see the reading to the left of this vertical line. So in this case it will be 10, this will be 11, right? So that will be the main scale reading. This is main scale reading, which is nothing but 11 millimeter. Now what is n? So this mark on the circular scale is coinciding with the reference line, and it is 65. So let us put the value, and zero error is nil. So it will be 11 millimeter plus 65 times the least count, which is 0.01 millimeter minus 0. So it comes out to be 11.65 millimeter. So that is the reading. Now let us see one more question based on the same concept. Main scale has 1/2 millimeter marks, and in 1 complete rotation the screw advances by 1/2 millimeter. So pitch is 1/2 millimeter, and the circular scale has 50 divisions. So the least count will be pitch divided by number of division on the circular scale. So it is 0.5 upon 50. So it will be 0.01 millimeter. So we got the least count. Now let us let us find the reading. So if you look at this diagram, the reading to the left of this vertical line is 6.5. So that will be the main scale reading. So it is 6.5 millimeter, and this division on the circular scale is coinciding with the reference line, and it is nothing but 43. So reading will be main scale reading plus n times the least count minus 0 error. No information is given about the 0 error, so I can treat it to be 0. So it will be 6.5 millimeter, n is 43, least count is 0.01 millimeter, 0 error is nil. So 6.5 plus 0.43, 6.93 millimeter. So that is the answer of this question. Similarly, we can find the reading for these two cases, two separate cases, right? So this you can practice. I'm keeping this as a homework for you. Now let us see this question which came in JEE based on the same concept. In an experiment to find out the diameter of a wire using a screw gauge, the following observations were noted. The screw moves 0.5 millimeter on main scale in one complete rotation. So pitch is 0.5 millimeter. Total number of division on the circular scale is 50. So least count will be pitch divided by number of division on the circular scale, so which is 0.01 millimeter. Main scale has a reading of 2.5 millimeter. Main scale reading is 2.5. So MSR is 2.5 millimeter. 45th division of the circular scale is in the pitch line. So pitch line is nothing but the reference line. So N is 45. Instrument has 0.03 millimeter negative error. So 0 error is minus 0.03 millimeter. Now what is the diameter? So the reading will be main scale reading plus n times the least count minus 0 error. So main scale reading is 2.5 millimeter. N is 45, least count is 0.01 millimeter, minus 0 error is minus 0.03 millimeter. So this comes out to be 2.5 plus 0.45 plus 0.03. So it will be 8, 9, and this will be 2. So 2.98 millimeter. So option C is the right answer. Now let us see this question based on the same problem type. In screw gauge, there are 100 divisions on the circular scale and the main scale moves by 0.5 millimeters on a complete rotation of the circular scale. So we have given pitch as 0.5 millimeter. So the least count will be 0.5 millimeter divided by number of division on the circular scale, which is 100. So it will be 0.005 millimeter. The 0 of the circular scale lies 6 division below the line of graduation when two studs are brought in contact with each other. So it means we have a positive 0 error because 0 is below the reference line. So positive 0 error. And n is given as 6. So 0 error will be 0 plus 6 times the least count. So 6 times 0.005 millimeter. So that will be 30.03 millimeter. When wire is placed between the studs, 4 linear scale divisions are clearly visible. So main scale reading will be 4 times main scale division. While 46th division of the circular scale coincide with the reference line, and n is 46, the diameter of the wire. So here, since we have given pitch to be 0.5 millimeter, it means we can measure 0.5 on the main scale. So main scale division is nothing but 0.5 millimeter. So it will be 4 times 0.5 millimeter, so that will be 2 millimeter. So reading will be main scale reading plus n times the least count minus 0 error. So main scale reading is 2 millimeter, n is 46, least count is 0.005, minus 0 error is 0.03. So everything is in millimeters. So this will be 230 2.23 minus 0.03 plus 2. So 2.23 minus 0.03, so that comes out to be 2.20, and we have to find answer in millimeter only, so that can be written as 220 into 10 raised per minus 2 millimeter. So 220 is the answer of this question. Now let's see another question based on the same problem type. A screw gauge of pitch 0.5 millimeter is used to measure the diameter of a uniform wire of length 6.8 centimeter. The main scale reading is 1.5. So main scale reading is 1.5 millimeter. Circular scale reading is 7. So n is 7. The calculated curved surface area of the wire to appropriate significant figure is screw gauge has 50 division on the circular scale. So in this case, pitch is given as 0.5 millimeter. So least count will be pitch divided by number of division on the circular scale. So it comes out to be 0.01 millimeter. So we got least count, and reading for the diameter will be main scale reading plus n times the least count. No information is given about the 0 error, so we can consider it to be 0. So minus 0 error, so this will be 0, right? So it will be 1.5 millimeter. N is given as 7, least count is given as 0.01 millimeter. So it will be 1.57 millimeter. So we got the diameter, and we have to find the curved surface area, which is pi d times the length. That is the surface area, curved surface area. So it will be 3.14 times the diameter, which is 1.57, times the length, which is 68 millimeter. Right? So when we simplify this, 3.14 times 1.57 times 68. So if you look at 68, so this comes out to be 335.2, and the answer will be in square millimeter, but we have to convert this into square centimeter. So let us divide this with 100, so that will be 3.352 square centimeter. And if you look at 1.57 and 6.8, 68, this has two significant figures, it has three significant figures. So we'll round off the answer up to two significant figures. So here we have 5, and this is an odd number, so this will become 3.4 square centimeter. So option B is the right answer. Now let us see this question based on the same problem type. While measuring the diameter of wire using screw gauge, the following readings were noted. Main scale reading is 1 millimeter. So main scale reading is 1 millimeter. Circular scale reading is equals to 42 division. So n is given as 42. Pitch is given as 1 millimeter. 100 divisions on the circular scale, so least count will be 1 millimeter divided by 100, so that will be 0.01 millimeter. The diameter of the wire is x by 50 millimeter, the value of x. Again, no information is given about 0 error. We'll take it to be nil. So main scale reading plus n times the least count minus 0 error, this will be 0. 1 millimeter plus 42 times the least count 0.01. So it will be 1.42 millimeter, and we have to find, and this is given as x by 50 millimeter. So x will be 142 times 1 by 2, so that will be 71. So option 3 is the right answer. Now let us see this question based on the same problem type. There are 100 divisions on the circular scale and the pitch is 1 millimeter. So we can find the least count, that will be pitch divided by the division on the circular scale, so 0.01 millimeter. With no measuring quantity in between the jaws, the zero of the circular scale lies 5 division below the reference line. Since it is below, it will be a positive 0 error. And it will be 0 plus 5 times the least count, so it will be 0.05 millimeter. The diameter of the wire is then measured using screw gauge. It is found that 4 linear scale divisions are clearly visible while 60 divisions on the circular scale coincides with the reference line. So here main scale reading is given as 4 millimeter because pitch is 1 millimeter, right? And n is given as 60. So reading of for the diameter will be 4 millimeter plus 60 n times the least count. Least count is 0.01 minus 0 error, which is 0.05. So it will be 4, everything is in millimeters, so it will be 4.6 minus 0.05, so it will be 4.55 millimeter. So option 3 is the right answer. Now let us see this question. A pitch of a screw gauge is 1 millimeter and there are 100 divisions, so least count will be 0.01 millimeter. When nothing is put between the jaws, the zero of the circular scale lies 8 division below the reference line, so it will be having a positive 0 error, which will be 8 times the least count, so it will be 0.08 millimeter. When a wire is placed between the jaws, the first linear scale division is clearly visible. So main scale reading is 1 millimeter because one linear scale division is visible, and n is 72. So the radius we have to calculate. So the reading for the diameter will be 1 millimeter plus 72 times the least count minus 0 error. So it comes out to be, everything is in millimeters, so 1 plus 1.72 minus 0.08, so that will be 1.64 millimeter. So this is diameter, we have to find the radius, so radius will be 0.82. So option 2 is the right answer. Right, so so this question we have already discussed, so it's the repetition. Even this question we have already discussed. Now let us see this question. The pitch of a screw gauge is 1 millimeter and there are 100 divisions. Right, so again this question is repeated. Right, so let us see this question. Student A and student B use 2 screw gauges of equal pitch. Pitch is given as 0.1 centimeter. And there are 100 divisions on the circular scale to measure the radius of a given wire. The actual value of the radius of wire is 0.322 centimeter and the absolute value of the difference between the final circular scale reading observed by the student A and B is, right? So here if we consider the first case, figure shows the position of the reference O when jaws of the screws are closed. So when jaws of the screw are closed, we are getting, in this case we have a positive 0 error, in this case we have a negative 0 error, right? So for the first case, 0 error will be 0 plus 5 times the least count, and least count will be, in both the cases will be 0.1 centimeter divided by 100, that will be 0.001 centimeter, 0.001 centimeter, so that will be 0.005 centimeter, right? And the actual value of the radius is 0.322, or we can say the actual value of the diameter will be 0.644. So 0.644 centimeter will be equals to main scale reading plus n, let us say x division of A is coinciding with the reference line times the least count. Least count will be 0.001 centimeter minus 0 error, which is 0.005 centimeter. And for B, zero error is, it's a negative zero error, so that will be minus 1 main scale division plus 92. So 92 is coinciding with the reference line times the least count, which is 0.001. So it comes out to be minus and 1 main scale division, pitch is 0.1 centimeter. So 1 main scale division will be 0.1 centimeter. So minus 0.1 centimeter plus point, it will be in millimeter, right? Sorry, this is in centimeter only. So 0.1 centimeter and this will be 0.092 centimeter. So that comes out to be 100, so 0.008 centimeter with a negative sign. Okay, so that is the zero error in the second case. So the reading will be 0.644 centimeter equals to main scale reading. So I'm assuming in this question main scale reading is same for both the reading, for both the cases. Plus, let us say the circular scale reading is y for the student B times the least count 0.001 centimeter minus zero error, which is minus of 0.008 centimeter, and we have to find the difference. So what are we going to do? Let us take the difference of first and the second. So if we take the difference, we'll get 0 equals to 0 plus x minus y times 0.001 centimeter plus minus 0.005, and then we have minus 0.008. So this comes out to be x minus y is equals to 0.013 divided by 0.001. So this comes out to be 13. So x minus y comes out to be 13, and that what we have to calculate. So 13 is the answer. So I hope this question is clear. Now the last topic of this video is spherometer. So spherometer is a device which we use to measure radius of curvature of a spherical surface. So here, so that what you have to remember. So we use spherometer. Okay, identify the physical quantity that can't be measured using spherometer. So radius of curvature of a concave surface. So this is not the answer because we can measure that. And thickness of a thin plate. Yes, that can also be measured with the help of spherometer. So that is also incorrect. Radius of curvature of a convex surface, that is also can be measured. So it is incorrect. So the specific rotation of the liquid, it can't be measured. So it is basically at the microscopic level, and if you look at the instrument, it cannot measure that. So option 2 is the right answer. So here I conclude this video. So I have covered 26 problem types. So if you watch this video up till this point, I'm pretty sure your concept about this chapter has been cleared, and you'll be able to answer 1 or 2 questions that can be asked from this. If you find videos of this series useful, so it is highly recommended for you to join PracBee's revision program. So in this program, we're going to cover 10 blocks in 10 weeks, and we'll give you a target of 1 chapter per day, and we'll be able to cover all relevant chapters by the first attempt of JEE Mains. And how you can join this revision program? By clicking on the link given in the description. And one more thing you can do, please drop a comment. Let us know what else we can do for you to make this series better. Thank you.